Hi, my name's Clay. I'm from Lightstep, and this is a demo about how Lightstep and PagerDuty can work together before a code gets pushed to production. So, this is the Hipster Shop repository. This is Lightstep's kind of standard demo environment. You can find it on GitHub if you're familiar, if you're curious or kind of want to see the code. But this is a microservice monorepo, and the idea here is that this represents a bunch of different services running in production. And the reason I kind of mention that is that it's also a prerequisite of this demo or if using it in your own repositories too. You need to be on GitHub. You need to have GitHub Actions available for your account. The details vary depending on your GitHub account type. You can reach out to GitHub for more information on that. But ultimately, the idea here is this is really for a repository that's running in production, and you want to bring in the context from PagerDuty and Lightstep into these GitHub workflows, into a pull request workflow. So let's actually see what that looks like. So first off, a little bit of an explanation around GitHub workflows and how they're configured. Not surprisingly, since this is GitHub, workflows are defined in code. So in the .github workflows directory, which is a special directory that GitHub Actions kind of connect to, you define a YAML file. And there are lots of different types of YAML files. You have a lot of flexibility on kind of what workflows you build. There are a lot of great examples. If you click on Actions in a repository, you can see some pre-built ones. But in this case, we've defined a custom workflow that runs the action and uses the Lightstep actions in particular to kind of inject that context that we were just talking about during the talk. So with that set up, what that means is that whenever anyone runs a pull request, you can see it here on pull request. Again, the documentation for these workflow files are on GitHub itself. We won't really get into that so much, and we've got some good examples for you after. But the idea here is that whenever you run a pull request, the action is going to run. It's going to call out to the Lightstep and PagerDuty APIs, and then kind of bring in that context into the pull request itself via comment. So let's go ahead and open up a new pull request. We'll close this one first, just to show it from scratch here. So we'll go back into pull requests. We'll open a new one. We'll select a branch that has some new code changes, and we'll create it. So go ahead and create it, not with a comment, not a best practice, but this is just for example purposes. And we've got new pull request add instrumentation number 6. This pull request is just adding some additional instrumentation to kind of add additional telemetry to this project that's being running in production. So a couple of new things that you might not have on regular pull requests. You'll see that some checks haven't completed yet. And the reason is that it's one of the new checks we added in the GitHub workflow. The Lightstep pre-deploy check has been kicked off. And so if we click details, you'll see it's actually running. It's going through a number of steps to actually kind of set up this, but the Lightstep pre-deploy check runs. It's calling out to the PagerDuty API, it's calling out to the Lightstep API, and getting information around the health of production and who's on call to kind of surface that in the pull request itself. When the action and workflow finishes running, you'll see there's a green check. That means everything was successful. If not, you'll get a red check with an error message. Typically, that means you haven't set things like a required API key or an environment variable. And we can jump back into pull request, add instrumentation, and we see this new comment that was added 34 seconds ago. So a couple different things are going on here. First of all, the actions determine that there are things going on in production based on conditions that have been pre-configured in Lightstep that indicate that it might not be a really great idea to immediately click the merge pull request button. And the important thing to note here is this isn't a clear-cut case of there's an open incident or that there's a Sev1 or Sev2. This is kind of more in that weird gray area of that there's some monitoring condition that's been set on some related service. It's not necessarily a major incident, otherwise you would know, you would be paged, or your teammates would be on it. But there's something going on just that's worth further investigation. So if we click on Lightstep monitoring conditions here, it'll bring you over to Lightstep, and you'll see that there's kind of three different things going on. One, we have some conditions on the checkout service and the front end service, and we've set some thresholds to say, hey, based on our own understanding of the service, this is all customer configured, that, latency seems a little bit high. It's not incident high, but it's just a little bit high, kind of a yellow light, if we want to think of it as a traffic light status. So if we jump back into the pull request, that's a great question for the on-call engineer. Kind of who's the expert to give a quick Slack shout out to, or maybe look at a runbook to kind of understand what that is before you actually push this code change. And in this case, because we've integrated with the PagerDuty API, or specifically the on-call part of the PagerDuty API, we know the person that's responsible for it. In this case, it's just me. But if you go ahead and click on that, it'll take you to the PagerDuty service page where you can get more historical information around, open incidents and kind of what's been going on recently in that service. So I'll go ahead and switch over tabs to that service itself. And we're brought to the PagerDuty service page. But there's some kind of new things going on here, and this is brought to you by the new change event API. First of all, you see in the recent activity, there's no incidents, so that's really good news, especially if you want to deploy a change to production. You wouldn't want to really do that with a lot of open incidents. But you see a recent change, and let's go ahead and click on that recent change. The Lightstep pre-deploy check failed, which, if you'll recall, is exactly what this GitHub kind of comment on the PR said. So we brought in this context into PagerDuty as a change event, and we've actually added some contextual links. So first is the GitHub commit itself. So this is the pull request change that triggered the action that triggered the change event. So we can see what code was changed. And the other thing is we can also see the Lightstep service snapshot. And the Lightstep service snapshot is a really interesting view of the production system at a point in time, gathered using distributed traces and Lightstep instrumentation. And so this is a great place to jump off to Lightstep to kind of dig deeper into understanding, well, we know the latency condition was kind of high, maybe not a major issue, but let's see if we can kind of understand that more from this snapshot. So let's click the snapshot, and we're brought into the Lightstep Explorer view. A couple things to note about the Lightstep Explorer in general. In this case, it's a snapshot for a particular point in time. You'll see it's today, a few minutes ago. But it also supports open-ended querying. So if you wanted to switch the time window to right now and write a different query, completely supports that. But because we've done this snapshot proactively from the GitHub action workflow, we already have kind of collected the data, the traces, and the latency that allow you to kind of understand, well, what's really going on here. So the first thing to show is the service diagram. We know that the front-end latency was high, but then because we're gathering distributed traces, we're actually able to understand the connection between all of these different services. So in this case, we know as the front-end service, we see it kind of calls out to all of these different services too. In yellow here, we see that the checkout service in particular is contributing more latency operation. So at a very high level, you kind of see the map and you know where the slowness is, which is pretty good. That might already be enough for you to know, like, okay, this is kind of a serious problem, might need to go back to PagerDuty and kind of start a conversation with the on-call engineer. The other thing you can do is really start to filter and group these spans to kind of further refine your hypothesis of like, this does seem kind of like an issue. So first of all, we'll click this checkbox, show all spans and traces, which basically brings the context of all of the other services that talk to the front-end service. And then we're going to group it by the service name. So for that point in time where the snapshot was created, we know that traces were collected that go through all of these different service types, the checkout service, the card service, the front ends. But because we're aggregating it, we also know where the error rate is and where most of the latency is as well. So immediately, as we saw in the service diagram here, you can see that The average latency is mostly in the checkout service. And again, if we look in the correlations tab here on the right-hand side, it also identifies that 58% of latency, here if we mouse over in the histogram, is really coming from this get cart operation on the Hipster Shop cart service. So again, instead of kind of digging through logs for 9 services, all of this is really just surfaced in aggregate automatically with a few clicks. So the idea here and the hope is that this allows you to go from some kind of proactive condition in GitHub, knowing that something might not be quite right. It's not yet an incident. It's not yet really even an alert. But just that general context of production and specifically how all these services are talking to each other and where latency is in those services is a really good point to kind of know and understand before you're about to make a code change that's going to impact this critical path. So we hope, we hope in this case or in this demo, especially with this microservice environment, that just having links to these products, knowing who's on call, allows you to kind of investigate the problem quickly, understand what's going on, what the dependencies are, go to the right solution, and then ultimately involve the right people or ask the right questions to kind of go ahead and push this change forward and click the merge pull request button, which we know everyone really wants to do and doesn't want to leave this open for a really long time. And the other thing to point out too is this is obviously a kind of a demo environment, a fake repository, but because it's a GitHub workflow, you can really customize this to run whenever you like, including via API, including via like different kinds of checks. The GitHub Actions workflow, kind of the way it's set up, and because it just is kind of configured as code, you can do a lot of different things with it, including writing your own kind of error messages or kind of bringing in context from different tools. But we really hope, particularly for kind of development teams and operations teams, where on-call is shared, that this kind of is a really quick preview of the things you really need to know before you click the merge button and it kicks off some sort of automated or potentially manual deployment process. So we're super excited to share that with you today. We hope you give the action a try, and we'll jump back into the talk and kind of wrap things up.